I've got a few things I want to talk about, and then I'm going to sort of open it up. I'll probably take about 2/3 of the class, and then I'll sort of open that last part up for general questions. But feel free as I go through to ask questions. I'm going to try to move us along so that we cover the whole first unit, at least topically, perhaps not total content-wise, but topically. But other than that, please feel free to ask questions. Before we start on what is in the exam or the prelim, let's actually talk about what the prelim is. I designed the prelim so that it will take about the entire time of class. So it's being given to you this Friday during this time period in this room, which is in fact to your advantage. It turns out that when you study or hear about a course and you take exams in the same room, that you actually perform better. Whatever. Why? I don't know why. So let's talk about what the material is, how it's going to be presented. It's a mix of materials. I use a mix of formats, I should say. There's going to be multiple choice. There'll be fill in the blanks. There'll be matching. There'll be short essays. There'll be sentences and one-off word type of fill in the blank type of stuff. Okay. The design is set up because I know people perform differently under different types of performance evaluations. Some of us are really good at writing essays. Some of us are not. So what I do is I try to do a distribution of all different kinds of stuff. Okay, so everybody has an opportunity to perform. Okay? All right. Now, let's actually talk about the level of which I'm expecting you guys to perform. Okay, this is a 2,000 level course. I expect you to know first principle stuff. So if I asked you what the 5 soil forming factors are, you should be able to repeat it to me. Okay? But I don't really want to have a bunch of parrots. Okay, what I really want is you to be able to understand what those factors in fact mean. So if I ask you, the questions I'm going to ask you, yeah, we'll ask you what the 5 soil forming factors are. In fact, I assure you I'm going to ask you that question. So know what they are. Okay, but more importantly, what do they in fact mean? What's the implications of these things? Because I will in fact, and I assure you I will ask this question as well, I will ask you, what does X mean? Why is it important? I might not say it in that sentence, but I'm going to be in essence asking questions directed towards finding that out. Okay, why is parent material, one of the 5 soil forming factors, so important? Now I'm not going to be asking it blatantly like that because that's a chapter of a book right there. Okay, but that's the types of questions, that's the type of information I'm going to be wanting back. Okay, so what's to do to sort of get you guys in the frame of mind, we're going to play a game. And this is called the connections game, okay? And we're going to be making this game, we're going to be next unit, we're going to be doing this a lot, okay? But I want to introduce you to today, okay? And what I'm going to do is I'm basically going to put a couple terms on the board, and then we're going to make the connections between them, okay? A logical, not well, you talked about it in lecture, that's not the connection, okay? The connection is, how do these terms connect logically in a scientific fashion related to soils? Sound good? Okay. Let me see, which one should we start with? Okay, we'll use this one. Temperature, moisture, organic matter. How do they connect? How are they related? What is related about them? Okay, the very first part of it's fairly easy. I mean, you can say this is climate right here. Okay? But how, in fact, does temperature and moisture connect to each other? A hotter system is not necessarily a drier system. But a hotter system, you would expect to start seeing more evaporation. Okay, and if you have plants in the system, you would expect to find more transpiration as well. Okay, now as evaporation happens and transpiration happens, you're cooling the temperature, right? Okay, there's a nice connection. Are there any other connections there? In fact, there are. I can come up with 3 or 4 more. Go.
If the temperature is low and the moisture is high, then you'll have less like decomposition, and so you'll have more organic matter.
So you're making this connection. So low temperature, high moisture, increase in organic matter storage in the soil. Perhaps not primary production, but you'll start seeing this. In fact, you probably get this. But you should start seeing this, an increase of organic matter in the soil. Nice connection. Does that make sense? Those are the types of things I'm going to be asking you. No, actually, I'm only going to be asking one of these on this exam. But these are the types of questions relationally that I'm going to be asking you. Why is plant material important to aridosoils? Is it important to aridosoils? If we talk about aridosoils and I want to find the climatic issue or whatever the soil forming factor is, what is the driving soil forming factor for aridosoils? Climate. Okay. What is the driving factor for entosoils?
Recent disturbance.
What?
Recent disturbance.
Recent disturbance. Well, what's the driver for it? What is the characteristic? I mean, it's a recent disturbance, but what is it if we're looking at that soil and we want to have a characterization idea of what that soil, what factor do we in fact look for? We can say time, but there's another one.
Poorly formed horizon.
Not poorly formed horizons. I mean, that's an artifact of this. It's an artifact of time. Parent material. Whatever the parent material is, yet time hasn't impacted it yet. So in a sense, time is important by its absence. But parent material is the driver.
Could you also
Go.
say climate in that instance? Because a lot of entosoils are based on like.
Well, you could relate it to sort of these guys. So a glacier, a low temperature, lower water system, that's relating to time. So right there, I can throw out 3 more terms. Time, parent material, climate. Relating to entosoils. Make sense? That would be in essence your story. Okay? Do we feel comfortable with that? That in essence is the things that you should be thinking about. Now, let's talk about the specifics of what you guys should be thinking about. Let's start with basically looking at the topics and the subject areas. Okay, this is right on the first lecture unit, Unit 1. Okay, I started the class by talking about the Finger Lakes, and I started talking about, yeah, that's what I started talking about. I started talking about what is the landscape that we're living in. Okay, and I told you that story because I wanted you to have an understanding about how these materials are distributed, how these things are spread across the landscape, so that you have an understanding about, okay, well, if we start talking about the forming processes and the factors, what should we be expecting in this landscape? Okay, what are the factors that are driving soil distribution and soil production and basically the environmental system in this area? Okay? Which then led right into, because we're talking about soils, I started talking about soil architecture. What is it that makes up soil? And that's where I introduced the idea of soil volume. Okay, I didn't want you to think of it as a material. I wanted you to think of it as a volume. And why do I want you to think of it as a volume? Because where's everything happening? It's not in the, well, it's in the pores, but it's at the interface between the solid material and the void material. And that's where we did that Venn diagram. You know, soils are the interface of the atmosphere and the hydrosphere or the lithosphere and the biosphere, right? Everything's happening at that edge. It's this edge effect, okay? So we started talking about what the nature of that material is. Okay, what is in fact are we looking at? We started talking about texture, okay? And I also brought in the idea of color, but I moved pretty fast basically into structure. Okay, what is texture, particle sizes, into structure? Okay, what is the arrangement of the solid part of that volume? Because that's going to determine those edges, right? Okay, then we moved into soil formation and soil processes. The soil formation is the 5 factors. Okay, what are those 5 factors? How do they drive the system? Why are they important? I mean, why do I even sit up here and talk to you about the 5 soil forming factors? Okay? And that we can take right back to that conversation we had about the connections game. Okay. We had the factors, and then we moved into the processes. How are these factors interacting with each other? They're interacting through addition type of processes, things being moved into the system, new parent material, rainwater, organic material, nutrients, and also things being lost from the system through losses. Anything that can bring something in can also take it away. Okay? Then we also talked about what's happening within the soil. Okay, so we have translocations, things moving downward, things moving upward. And then we also had transformations in the system. How are these systems in fact changing? The example there I think I gave was organic matter. You know, organic matter translocation being pulled down by a worm, and then it's being decomposed, and it's becoming a food source, and that organic matter is basically being decomposed and shifting and changing, all within the soil material. Okay, and what is the result of that? Decomposition produces acids. Those acids then weather material. That material then starts to change, but it also solubilizes stuff that in turn moves through the system. Okay? All right. After we talked about soil processes, we started moving into soil weathering. And we talked about what it was in general, but then we sort of broke it apart into physical weathering and chemical weathering. Okay, we started with the physical weathering because that seems always to be the easiest one to connect to. Okay, and we had 5 different types of physical weathering. Okay, we had sort of the physical things smashing together, but we also had sort of the gross geologic ones where I'm having overburden release, and so I have a pressure change in the material. Okay, so if I have a big mountain or something like that, or a big rock that's way down underneath the top of the soils of the surface, and it starts to get exposed, the pressure that's being released on that will crack the system because the tops will be less, there'll be less overburden than on the bottom, and so you're going to have a pressure change. We also talked about sunlight hitting something and heating something, and it sort of, so I have a heating system where the surfaces are warmer than the interiors, and so the surfaces expand, very similar to the pressure ones. Okay? We also had water moving into the systems, and the water moves into the system, and the system gets cold, it expands, it cracks things. And then the last one we had was biological, you know, where organisms move into a system, and that was my Ansel Adams picture. I don't know if you guys remember that one, you know, where I had a tree going in, and it basically looked like a wedge, and you could see the two rocks on either side. Okay, and those were the 5 physical weathering processes. Okay? Now, relate that back to, I can't see it at the moment, relate that back to these processes and parent material. Okay? We're modifying a parent material through weathering. Okay? And that weathering is due, in some cases, due to climatic conditions, in some cases not. Okay? That's going to affect the processes, which then just continues the cycle. Okay? Then we started talking about chemical weathering. Into the physical, now we talked about the chemical. And I talked about 4. Do you guys remember them? Hydrolysis, hydration, redox, and dilution, sort of carbonation type of process. Okay? Okay, each one of those was slightly different, but each one of those are basically literally changing the chemical structure of the molecule that makes up that material. Okay, it's modifying it. In some cases, it's totally dissolving it. Okay? All right, from there we went into soil mapping. And I did this because, for a couple of reasons, but I wanted, at this point, I wanted to give you guys sort of I wanted to sort of revisit this idea here where we're looking at this sort of landscape. I wanted to revisit that. And we started by talking about sort of the geomorphics, the geology of the system, the geomorphology. Okay? But I wanted to start bringing that down to where the soils are. Okay? We've talked about all these alteration processes. We've talked about all of these factors that control the distribution of soils. Well, let's actually look at what that distribution looks like. And then we started talking about soil mapping. And at the same time, we talked about how we map and what it is that we, in fact, take a look at. Okay? We cannot, in fact, look at processes. We don't live long enough. We don't have the right type of instrumentation to take a look at a process from 0 to n. But on the other hand, we can look at individual characteristics that we can then use to measure changes. Okay? And that's what we're looking at characteristic-wise. We're looking at slope. We're looking at colors. We're looking at textures. All the architecture type stuff. Okay? All the chemical kind of stuff. But sort of snapshot pictures. with the understanding, the realization that we're looking at a system that is changing over time. Okay, we've had 10,000, 15,000 years of processes occur here, and that's why we talked about the geomorphology, and then we started talking about the soils. Okay, questions so far? I know I just went through a whole first 3 weeks right there. Go.
For chemical weathering, do we need to know like the chemistry of each of those?
At this point, you don't need to know the chemistry. Next unit, you will. We're starting to start talking about a couple of in particular. But in this point, I want you to know what they are and what do they do. I don't need you to know, the carbonic acid reaction. I do not need you to know the carbonation reaction.
So what is that one? 'Cause other ones,
The carbonation reaction?
yeah.
That's basically a dissolution of calcium carbonate. Okay, so water moves into the system, it's got acid in it. It reacts with the calcium carbonate, and the calcium carbonate literally dissolves. And the calcium ions and carbonates was then combined into a CO2 reaction, making basically bicarbonate. Okay, you don't need to know that part of it. You just need to know that the system is dissolving. Then and that was just an example of dissolution. That was just one of a multitude of different dissolution ones. Okay, we good with that so far? Cool. All right. We then went into, since we had talked about the solid part of this volume, I really wanted to start making the point, well, we've talked about that part, let's actually talk about the void part. What happens in that void part? And that's where we started talking about water. Okay? And this is where I introduced the idea of soil potential, water potential, total potential. Okay? But I really was mostly talking, I did talk a lot about cohesion, adhesion, capillarity, issues of capillarity, but really what we talked mostly about was water movement. Okay? Infiltration, the stuff driving the water into the system, and once it's in the system, how it moves there. Okay? And that's why I talked about the potentials, because I wanted you guys to see how these things move into the system, how water moves into the system, and how it moves within the system. Now, why is water so important? Water's the driver for a lot of the physical and chemical reactions that we see, because it's controlling a lot of the biology. Okay? And so water movement is really pretty key. Okay, so we then also talked about properties of the soils that in fact modify infiltration and subsurface flow. Okay, so we talked about soil sealing, and we talked about slope, aspect issues like that. All right? Questions? Does that sound? All right, the next thing if we talked about the soil water, we really needed to talk about the soil air. And that's what we talked about the tail end of last week. And this is when we started getting into redox potential. Okay, now that is used as a segue for the next unit, but when you're talking about this void space, you've got to talk about the oxygen in that soil atmosphere. Not the atmosphere up here, the soil atmosphere down here. And then I talked about the differences between that atmosphere. Okay, so the first thing we talked about was, well, this is the atmosphere up here, and these are the constituents of it. And these are the atmosphere down in the soil, and these are the constituents of it. And you can see that they were different. And if they were different, we needed to start talking about the exchange. Just like we had talked about the water exchange, infiltration, subsurface flow, we also needed to talk about the air exchange. Okay, how's the air, the gas that's up here moving down here, and how's the gas that's in here moving up here? Okay, there aren't any plants photosynthesizing down in the soil, but there are a lot of organisms respiring down there. Okay, so there's definitely an oxygen gradient and a CO2 gradient, and how that moves. Okay, and in fact, how that is influenced by the soil water. Okay, then we started talking about, okay, well, if we're talking about organisms, we need to start talking about respiration. Okay, and we started by talking about oxygen respiration, us, obligate aerobes. And then we started moving to the system. Well, if the system's losing oxygen, whether it's due to water or respiration, we're now going to be moving into a system where organisms are using other things to respire. And that's where I introduced the electron potential, the electron tower, and all that. And I started looking at these pairs, which none of you guys got, right? Has anybody reviewed that electron tower? And more importantly, which it's actually not that important, what's more important is looking at all these reactions that are happening and why they're happening. Okay, as oxygen, good yawn there. As oxygen, good timing. As oxygen decreases, we're looking for alternate forms, or not us personally, but the organisms are looking to survive. And so as a result, they're looking for alternate forms of molecules that they can use as electron acceptors so they can get energy. Okay? They also want nutrients, but it's a lot about energy because it's the energy that allows you to do all the other stuff. Okay? You want nutrients because that's how you build your body, but you want the energy to be able to do that. And so we went through a series of different reactions. I call them half reactions, but basically we're looking at these reactions turning from a molecule from one thing into another. Now that's the respiration part of it. Next unit, you're going to start seeing that these products themselves become extremely important. Biological activity produces, respiration with aerobic systems produces basically 3 different products. Does anybody know what those 3 different products are? I guess you could say 4 because we also talk about biomass. If you're breathing, what are you doing? You're producing CO2 and
Water.
definitely coming out. Now what else are you producing? Biomass, and why do we respire in the first place? ATP, energy. Okay? So those 4 things are basically driving this respiration. Okay? And the waste products are potentially a product that something else can use, but it certainly is a product that's going to affect the environment in which it's in. Okay? If I'm using oxygen to respire, okay, and I'm producing CO2, there's a consequence of having that CO2 in the system. First off, it reduces the amount of oxygen because I'm breathing the oxygen in. But that CO2, when it reacts with water, what is it going to make? It's going to make a carbonic acid. Okay, and that acid now becomes, and you guys have heard me say it before, give me weak acid in a million years and I'm going to weather away anything. Well, you give me a weak acid in a couple weeks and I'll weather away something. So there's results from this. And we're going to talk a lot about that next semester, but these paired reactions are really important, and understanding the soil atmosphere and the electron tower gives you an idea about how fast those reactions are going to occur and when they're going to occur. Okay? The last thing we talked about was energy. And this is when we brought in the sun into the system. And I started talking about, move it down. And this is when we started talking about the solar radiation coming in as long wave, or as short wave, sorry. As short wave coming in as short wave, and then moving into the system. And we talked about how it moved through the system. It can either break through, or it can be diffused, or it can be refracted, albedo type of effects. Okay? And then once that energy gets into the system, what happens to it? Well, it gets absorbed, and it gets turned into sensible heat, which then can, in essence, be re-radiated or reflected back out. Not the sensible heat, but the re-radiation. Okay? And so we looked at how this energy is moving into the system. And then we actually talked, once we got the energy in the system, well, what happens to the energy then? Okay? And the first thing we talked about was the specific heat of things, how the heat capacity of things. How much energy, if I have energy striking an object, what happens to that object? And that's when we started talking about things heating up. Right? So that energy heats up, and every object has a different specific heat. It takes a certain amount of energy to heat up an object. Okay? Well, once that object is heated up, that energy can then be transferred. Okay? And that's when we started talking about heat, thermal conductivity versus thermal capacity. And we started talking about how that energy moves through the system. Which brings us right back to the 5 factors. Because if I start talking about temperature, I'm talking about climate. And that's when we started talking about mulch and modification of mulch, and I used the example of garden bed to say, okay, well, why do we want to modify this climate? Well, in the springtime, I want to heat it up because I want my plants to germinate. I want my seeds to germinate. I want my plants to start respiring. I also want to heat it up because I want to get the water out of it because I want to make it easier to heat up, but I also want to get the water out of it so my plants can start respiring. And then in the middle of the summertime, when the soils are already heated up, and we got a lot of evapotranspiration, I actually want to put the mulch back. Okay? And why does mulch work? Heat capacity and heat conductivity. Right? Okay. That in a nutshell was the first unit. Do we feel fairly comfortable with the generalities of that? Okay, let's start opening it up to specifics. Okay, let me go back to the very beginning. We can skip over the Finger Lakes, but let's go to soil architecture. Do we have any questions there? We talked about the texture, and we talked about the three individual soil separates and the combination thereof making the textures. We also talked about the coarse fragments, the stuff that's larger than that. So it's basically that 2 millimeter break. I do expect you guys to understand that there's coarse fragments and then there's the fines. And those fines then, the soil separates then become, the combination thereof is the soil texture. Okay, why is soil texture important and so on. Okay, pop question, is organic matter texture? No, okay. All right, so any questions in sort of that texture zone? How about structure, when we start talking about structure? Go.
There's a slide in there about organic matter, and it says that improves structure, improves drainage, like improves nutrient quality, and decreases bulk density, but then it says suspect is more or less present for drainage and toxicity issues.
Yeah, that was a slide. So it was one of the slides that I gave really early because I wanted to get you guys into it because we were going to be going out to the field that week. And I wanted to say, okay, what are you going to see out there? And so I had a slide that basically said organic matter and what benefits and potential issues are with organic matter. So organic matter, if I put organic matter in the system, I'm certainly going to get better infiltration rates. Okay, and I'm also going to get more of a sponge effect, right? Fine textures, but lots of big pores, but lots of little pores. It's going to hold water really well. Okay. Also, because it's organic matter, it's a product of material organisms that are going to start decomposing, that it helps with soil structure, which in turn is going to help with infiltration and soil water holding. But I also put in here, there's some suspect issues here. If you start seeing lots and lots of organic matter, now you guys remember that pie chart I said, you're generally going to find around 2 to 3% organic matter in agricultural soils, maybe up to 5%. Okay, when you start getting more than 5% organic matter, this is not necessarily a bad thing, but if you start seeing more than that, there is something going on that is potentially accumulating that organic matter faster than upland soils, okay, i.e. a wetland, for example. So if I start seeing those accumulations, I should be suspicious. This is not necessarily a bad thing, okay, but I should be suspicious that there are other things going on that I should be aware of. Now, it could potentially be a bad thing, because if I start seeing organic matter accumulation and has nothing to do with anaerobic systems, I might in fact have some sort of toxic effect where the organisms aren't able to do decomposition because the material itself is poisonous, whatever. Okay, so does that make?
Yeah.
Okay. Now, the other thing that I sort of brought up, and we sort of glossed over really quickly, but I brought it up in lab, is this idea of bulk density. Okay, we started talking about things getting denser and denser and denser. And I don't think we actually said what the measure is, or actually the formula for bulk density. Do you guys remember? Did we talk about that? I did? I think I did. I don't know if I did. Okay. But basically, when we talk about bulk density, and I brought up the idea of 1.65, I think I did that in lab. Yes? Does not sound familiar? Okay. Bulk density is a measurement of how dense a material is. Okay? And we measure it by basically the weight of the individual particles divided by the entire volume. Okay? We are not measuring what's in the pore spaces, so we're basically looking at a dry soil. Okay? So if we're looking at a bulk density, the bigger that number is, the denser it is. Okay? And so basically you're looking at weight over a certain volume, and by default we basically do grams over sort of cubic centimeter. I mean, okay? And the rule of thumb is when you get to a bulk density of 1.65 grams per cubic centimeter, 1.65 tends to be the density at which roots start having problems or serious problems moving through that material. Okay, go. Well, particle density, the volume of a particle, particle density versus bulk density. In particle density, we're just interested in the density of that individual particle. Okay, so if here's my volume, okay, say it's a cubic centimeter. All right, here's my cubic centimeter, right? Okay, a particle density is, say I have a sand grain in here. The particle density would be just the density of that particle versus a bulk density, which would be the density of every particle that is in this volume. Right? So a particle density is going to be a lot denser than a bulk density. But we shouldn't expect to see a root driving through this. Okay? But on the other hand, we should expect to see roots getting in between the particles. But if that density of that volume gets tighter and tighter and tighter, we start seeing issues with roots. And if we have issues with roots getting in, you know there's going to be issues with other water and air moving through that system. Okay? All right. So we went through soil architecture. And then we went through soil formation, or soil forming factors, I should say. Paramaterial, climate, biota, relief, topography, and time. Yeah, any questions there? Pretty straightforward. And then we did processes. Additions, losses, translocations, transformations. Go.
I have a question just that how do they differentiate between, for example, a translocation from one horizon to another can be also confused with a loss from this?
Yeah, so that's a good question. So if you have how do you distinguish between a translocation versus a loss? Conceptually, a translocation is within the same head-on unit that you're looking at. So even if it got a loss from up here down here, we consider that a translocation. A loss is when I literally lose something from this head-on and it goes someplace else. Okay, so I might have a loss from up here moving down here. We term that as translocation. But if I lost it from here and it went all the way through the system and then leached out the bottom, that's a loss. Okay, this is the translocation. The minute it moves out, it's a loss. Now, the loss could be coming from erosion. It could be coming laterally. It also could be coming straight down off the bottom. Does that answer the question? Okay, go.
When we talked about the slope aspect and how that affected erosion, what was?
So slope came in that we talked about aspect, and we talked about aspect in certainly 2, maybe 3 ways. The first one was we talked about aspect, i.e. as if it was a northern latitude and the sun's coming up the south end. Okay, so if this is north and I have a slope that's like that and the sun is up here, the sun is going to be more directly shining its rays on this side of the slope versus this side. Now, depending upon where you are laterally, latitudinally, north or south, if the farther north you get, the warmer this is going to get, and probably if you get really far north, this is where most of the vegetation is going to be, okay, because it's warmer. Okay, but on the other hand, if this side is warmer, this is the side that's going to be wetter. Okay, so if I start moving south, almost into the desert zones, this side is actually going to be the side that has more vegetation because there's more water here. Okay, that was one thing that we talked about with aspect and relief. The other thing we did was we talked about basically water harvesting or material harvesting. And that's when we had the sort of the shapes of the material. We talked about the slope, deep soils up here, shallow soils here, really deep soils here. But we also talked about sort of the slough idea where I'm harvesting all the water here and I'm concentrating it here. So I'm going to certainly have vegetation patterns, but I'm also going to have weathering issues there. Okay, which goes back to this slope issue. This back slope right here is where I'm going to have most of the colluvial action. That's where most of that weathering is going to be coming across. Now, granted, the tops are going to be coming off as the shoulders and the back slopes get cut in, the tops will become that. But then we also have this stuff basically ending up down here. And those are basically the 2 primary drivers of topography. One is that aspect component, and one is actually the shape of the material. Go.
I know in the chart you were going back to the north versus south slope.
Right.
In the notes it says that the north side has shallower soil versus the south side, but is that actually just dependent on where you are?
So the question is, on the slide that I showed you, we had north versus south, and on the south sides we basically said you're going to find deeper soils than the north sides. But the reality is that is going to depend on how far north or how far south you are. Okay, because if you start moving south and I get more plants on this northern aspect in the northern latitudes, those plants are in fact going to start helping accumulate depth. Now, if this side is hotter, that heat is in fact also going to be a weathering effect. but water is really going to be the driver in those types of systems. Okay? Water modified by heat. Okay, so the farther north you go, the more vegetation and stuff I'm going to get on the north side, and so as a result, I'm going to get deeper soils over here. So someplace from the really northern latitudes to the not so northern latitudes, more towards the equator, there's going to be a break where you're going to see the soil depth changing from the south side to the north side. Does that make sense to everybody? Did anybody even follow that? Okay, so the idea here is that you're looking at these latitudes, okay, and if that's north and that's south, the sun's over here, okay? But as you get farther and farther south, the temperature is going to get warmer and warmer and warmer. At some point, that temperature is going to get so warm that the plants are going to start stressing, okay? And if they start stressing, they're going to be really sucking that water out. So in reality, the south side is actually going to be the drier. Okay, in both cases, it's going to be the drier one. But in the south side, when you get farther south, because you have no water, there's going to be actually more plants on the north side. Okay, when you get to the really northern latitudes, okay, yes, I've got sun over here, and I probably have more moisture over here. But in that scenario, the stressor is actually the cold, not the moisture. Okay, and so the warm side of the slope is actually going to be where the plants are. Right? Does that make sense this time? Okay. Went to sleep again. Okay, so processes, and then we moved into weathering. Okay, any questions about the weathering? Physical versus chemical? No? Go.
Can you go over the chemical really fast?
Okay, so there were basically 4 of them. One is hydrolysis. One is hydration. The next one is redox reactions. So you're basically looking at proton change, a water molecule change, or an electron exchange. Those are the first 3. And then the last one is basically disillusionment, where it's literally dissolving. And the example that we used there was calcium carbonate. And this is
You listed as slower, like the
slower, okay.
Explanations of what hydrolysis and hydraulic, etc. are. Like I have the 4 things, but I don't know what they do.
Do you know what they do? One is literally a proton. So it's a hydrogen ion, you know, with a plus charge. Okay, and it's, I think, by being, I'm not sure. I don't know what you're asking at this point. Okay. Yeah, go ahead.
So you're saying that the proton change is the hydrolysis weathering pattern?
Yeah.
And then the hydration?
Oh, now I understand. Okay. Okay. Hydration is the water one. Hydrolysis is the proton one. Redox is the electron one. And disillusionment one is the disillusionment one, dissolving one. Does that, okay, now, okay, got it. Sorry. All right, so we're good with that one? Okay, question.
What are like the implications of this? Like I get
Implications at this point, we're going to hold a lot of that's going to be for Unit 2. But the implications at this level are what is controlling that type of reaction. Now, we haven't talked about acidity yet, so we're not going to have proton concentration gradients and things like that. But at this point, I just want you to know what they are. Okay? All right. Okay? All right. All right, good? Go. Oh, okay. So the soil orders themselves. In fact, we did talk. I should have talked about that when we talked in here. I do expect you guys to know what the soil orders are, and I do expect you to have a concept of what they are. Okay. I don't necessarily need you guys to know what the chops are. Okay. What is the question? But if I ask you what a mola soil is, you perhaps won't know that it has a molic epipet, but you certainly should know that this is a soil that has high organic matter. It's a grassland soil. It's formed in grasslands, and it has high bases, high nutrient capacity, right? Okay, if I talk about an aridosoil, you should certainly know that it's climate driven. Okay, if it's an andisoil, it's volcanic parent material. Okay, at this point, I don't necessarily need you to know what are the andic soil properties and things like that. I don't want you to know that, in fact. Well, I do, but not right now. Question?
Do we have to know the first through 12 in order?
No, you don't need to know them in order. I'm not gonna be asking you, if I ask this taxonomic chop, because I don't want you to, I do want you to know the taxonomic chops. But at this point, you do not have to memorize the taxonomic chops. I just need you to know what the 12 orders are and what are the distinctive factors of them. What makes those soils what they are? If they're a spodosol, a mollisol, an inceptisol, and an entosoil, what are they?
So should we know like what the typhic and mesic and all that means?
No, at the family level, you don't need to know yet. So you don't need to know mesic moisture regime, or eutic moisture regime, mesic temperature regime. You don't need to know the families. It's you don't need to know it's CEC or anything like that. Active. You don't mix mineralogy. You don't need to know that stuff. Just at the order level at this point. Go.
We need to know like the base saturation.
Base saturation, you do not need to know. You just need to know that it's high bases. Okay, so that's the active, subactive, superactive. You don't need to know that.
What about the diagnostic horizons?
The diagnostic horizons you will not need to know, but you will. I literally mean this. I want you to know what the 12 orders are, and I want you to know I hesitate to use the diagnostic feature, but the characteristic that drives that soil. What is that soil about? Okay, let's go through the 12. Gellosols. Ice. Okay, spodosols. Forested soils, ash, iron, organic acid movement. Okay, cool boreal forest, we often think of it as. Okay, histosoils. High organic soils. Organic soils. Okay, ultisoils versus alpha soils. Alpha soils, young, clay, alluviation, high nutrients versus ultisoils, low nutrients. A lot of translocated clays. Okay? Iridosoils. Mollisoils. Inceptisoils.
Beginning to form.
Initial stages of formation. Entosoils.
No formation.
Okay, who have I forgotten?
Andesol.
Andosoils.
Volcanic.
That's what I'm asking for, okay? We feel much better now?
Yeah.
Okay, go.
What's a good character to tell like the soil from the mollisol?
What's a good characteristic to distinguish between a histosoil and a mollisoil? Mollisoils are these grassland soils again. Yes, they have high organic matter, but they don't have more than that 20%. Okay, histosoils more than 20, and often 100% organic matter. A mollisoil is still a mineral soil. Histosoils are organic soils. There may be mineral material in them, but they're organic soils. Okay, another question was here.
How much do you need to know about hydraulic?
Conductivity. So the question was, how much do we need to know about hydraulic conductivity? I do expect you guys to know about infiltration and what are the forces that drive infiltration. And I do expect you to have an understanding of subsurface flow and what are the forces that drive that subsurface flow. Okay, and I mean that in two senses. Okay, one is I do expect you to understand the potentials. Okay, but more importantly, I expect you guys to understand what are the factors that limit or encourage or drive that water movement. So let's take infiltration, for example. What is going to drive infiltration into the soil? Besides the potentials. Soil sealing, size, number of pores, slope, delivery of water, those types of things. Okay, once it gets into the soil, connectivity of cracks, pores, number and size again. Okay, matrix potential gradients. Okay, those are the types of things I expect you to. Yeah, I'm not going to be giving you a pressure potential equation. Okay, but I expect you guys to know what the four potentials are, and if I give you an example of one of them, I expect you to be able to identify what it is. Okay, I have a high head, a sealed system, and I've got a fountain at the end of it. What kind of potential is that? I mean, I'm not going to ask it that way, but thinking about that, what kind of potential is that? What's driving that fountain? That's pressure, right? Okay, I've got a root cell that's moving water into its system. Osmotic, okay? I've got a dry soil versus a wet soil. Water is moving from the wet soil into the dry soil. What's moving that? Okay, I have a waterfall pouring onto my soil. Okay, though that's what I expect you guys to, at the level that I expect you guys to know it at this point. Go.
Will there be any equations?
I don't, so the question was, are there going to be any equations? I don't think there are going to be any equations. And if there are any equations, I'll be giving you the equation. I do not expect you guys to give me equations. Okay? Okay, any other questions?
How do you get to the part of the website where you can see the video?
I suspect that you guys haven't reloaded. I've had this question a couple times. If you go to lecture and you go to unit 1, like most people have done, you get to this point. Okay, you're going to get this page, and this is the exact same page that you had in the beginning of the semester. I suggest you reload the page because I'm betting that your cache is basically reloading an old image of it. So go up here, and click on the reload. Does that make sense to everybody? Has anybody? I know there were a couple people that have asked me this question. Has anybody actually tried to reload to see? So it has worked?
I actually had to empty my cache.
You had to empty your, wow, that's intense. Sorry. But the other thing, I mean, Chris, maybe I could hit you up for this. But the other thing is, if you can get to one of these, you can do this on YouTube. You don't actually have to go to this site. So if you get to one of them, you basically look at the author page, and they're all there. Is that right, Chris?
Yeah, so if you go to the YouTube user that has uploaded any of these videos, you can see the rest of them that have been uploaded, and we haven't put all of them up on the actual course website yet, but they're all going to be on the YouTube user, at least like the two from this week that haven't been put up yet. Those will be going up on the YouTube account.
And we'll try to get this thing up as well, the review. We're going to try that, right? Okay.
You know who the account is? Can you like write it down?
Do we know who the accountant name is?
It's called, the company name is Cornell TL. Cornell
I don't know, this is going to be too slow, I suspect, but maybe I can change the... So go to, oops, didn't mean to do that. What?
Click on the YouTube button and it'll take you to the website.
I just crashed. So right here, this icon, this hotkey link right here, if you click on that, oops, there they all are. Right? There's a lot of other stuff there too, but you should be able to find it. Okay? Cool beans? All right, I will see you guys. Some of you are going to see today and on Thursday. It probably is going to rain today, but we're going to be going out. Otherwise, I will see you guys Friday morning here, bright and early.